Sutherland-Hartman polygon clipping algorithm. This algorithm performs a clipping of a polygon against each window edge in turn. The order to clip the polygon should be clipping against the left side of the clip window, clipping against the top side of the clip window, right side of the clip window, and at last clipping against the bottom side of the clip window. The order follows from left, top, right, and bottom. Consider this example where the arrow mark has to be clipped. First, we consider the polygon and then we clip this particular polygon from the left side, followed by the top side, right side, and the bottom side. At last, after clipping the polygon, the figure which is showed is given in the D. In this clipping algorithm, we can consider four different types of cases. They are: case 1. If the first vertex of the edge is outside the window and second vertex is inside, then the intersection point of the polygon edge with the window boundary and the second vertex are added to the output vertex list. So that means we consider the square as the polygon and arrow mark is sent from the outside to the inside, where the intersection point from V1 to V2 is V1 dash. So while considering the save point, we consider the intersection point V1 dash along with V2 because the arrow mark goes from outside to inside in this case. Next, in this case, if both the vertices of the edge are inside the window, then only the second vertex is added to output vertex list. And here there is no any intersection point called as V1 dash. So the only point which is considered is only V2. So the output point, which is the save point, is only V2. Next case is if the first vertex of the edge is inside the window and second vertex is outside, then only the intersection point of the polygon edge with the window boundary is added to the output vertex list. Here, the input vertex is going from V1 to V2, which has the intersection point V1 dash. So the output will be only the V1 dash without considering the V2 because it is not existing inside the polygon or touching the polygon. So the output point or the save point will be V1 dash. Next, the last case is if both the vertices of the edge are outside the window, then nothing is added to the output vertex list. In this case, from the input point to the output point, no vertex is touching the polygon. So the output vertex will be null or 5 because no vertex or the no point is touching the given polygon. Based on these cases, if we consider a particular example, then it will be this. So consider one numerical. Here they gave a numerical as for a polygon and clipping window as shown in the figure. Give the list of vertices after each boundary clipping. This is the clipping window and the polygon given as this. If we clip the window based on the rules which we discussed earlier, then it will be the solution of this. So as we already know the order to clip a particular polygon, which is left followed by top, right, and then bottom. First, if we clip this particular polygon on the left side, then the left clipped output vertex will be V1 dash, V2, V dash 2, V3, V3 dash, V4, and V4 dash because here the point goes from V1 to V2 and the intersection point is V1 dash. And as we discussed earlier, if the vertex goes from outside to inside, then the output vertex we consider is the intersection point and along with the point which is inside the polygon. So that will be V1 dash and V2 and from V2 it goes to V3. The intersection point will be considered here, that is V2 dash, and that is followed from V2 dash to V3. So that gives V3. Next V3 dash, V4 and V4 dash. This is the output vertex if we clipped it from the left side. Next, if we clipped it from the top side, the output vertex will be V1 dash, V2, V2 dash, V3 dash, V4 and V4 dash. Like if we consider from the V1 to V2, the intersection point will be considered of course. So that is V1 dash and V2. From V2 to V3, so only the intersection point will be considered because here the vertex is going from inside to outside. So here V2 dash, and next from V2 dash to V3 dash, V3 dash to V4, V4 to V4 dash. This is the output vertex if we clipped it from the top side. Next, it's right clipped output vertex. It is V1 dash, V2, V2 dash, V3 dash, V4 and V4 dash. If we clipped it from the right side. So as usual, V1 dash intersection point and V2 and V2 dash, V3 dash, V4 and V4 dash. And at last, if we clip it from the bottom, it gives us V1 dash, V2, V2 dash, V3 dash, V4 and V4 dash. The same values we get it in the vertex. So at last, the final clipped polygon will be V1 dash, V2, V2 dash, V3 dash, V4 and V4 dash. So if we consider a particular polygon in the given clipping window, based on this following rules, this is how we clip a particular polygon from left, top, right and bottom. So that's it about this Sutherland-Hartman polygon clipping algorithm. Thank you.